Welcome to quicktechie.com. Let's continue with Palo Alto Networks Network Security Analyst Certification Training next module.
NAT Policy Objective. Let's talk about the NAT Policy Objective. NAT stands for Network Address Translation. It is a networking technique that changes the IP addresses, and sometimes port numbers, in the header of network traffic as it passes through a device like a firewall. Why do we need to change addresses? Because the private IP addresses used inside your network, like 192.168.1.100, cannot be used directly on the public internet. Also, you might want external users to access a server inside your network using a different IP address than its actual private one. The main objective of the NAT policy on a Palo Alto Networks firewall is to enable address translation. The NAT policy rules tell the firewall when and how to perform this address changing. This supports two primary use cases. 1. Source NAT, masking internal IPs for outbound. This is the most common type. When devices inside your network, using private IPs, want to access the internet, the firewall changes their private source IP address to a public IP address that is allowed on the internet, often the firewall's own public IP. This masks or hides the internal private IP addresses. Many internal devices can share one public IP address. This is essential for allowing multiple computers inside a network to share a single internet connection. Example, your computer, private IP 192.166.1.10, wants to go to google.com. The firewall changes the source IP from 192.168.1.10 to its public IP 203.0.113.5. Google sees the request coming from 203.0.113.5, not your private IP. 2. Destination NAT, allowing external access to internal IPs. This is used when someone from the internet wants to access a server located inside your network, which has a private IP. You configure the firewall to translate a public destination IP address that people on the internet connect to, into the private IP address of your internal server. This allows external users to reach your server even though they don't know its private IP. Example, someone on the internet wants to access your web server, private IP 192.168.1.50. They connect to your firewall's public IP 203.0.113.5 on port 80. The firewall sees this traffic and, based on the NAT policy, changes the destination IP from 203.0.113.5 to 192.168.1.50 and forwards it to the web server. So, the NAT policy's objective is to make sure network traffic has the correct source and destination IP addresses and ports as it moves between different parts of the network, like your internal network and the public internet, where different addressing schemes are used. Enable address translation. Let's focus on enable address translation. Imagine network traffic is like a letter. The header of the traffic packet is like the envelope, which has the sender's address, source IP/port, and the receiver's address, destination IP/port. Normally, when a letter goes through the mail system, the addresses on the envelope don't change. But in networking, sometimes we need to change these addresses as the traffic passes through a firewall. This process is called address translation. The NAT policy is designed specifically to enable address translation. It gives the firewall the instructions on how to change the addresses in the traffic header. When a policy rule dictates that NAT should happen for a specific piece of traffic, the firewall will change source or destination IP/port in traffic headers. Changing the source IP/port, this is typically done for source NAT. When traffic from an internal computer, using a private IP, goes out to the internet, the firewall changes the sender's address on the envelope from the private IP to a public IP address. It might also change the source port number. This hides the internal IP and allows many internal computers to share one public IP. Example, packet arrives at firewall, source equals 192.168.1.10, dest equals 8.8.8.8. Firewall performs NAT. Packet leaves firewall, source equals 203.0.113.5, dest equals 8.8.8.8. The source IP is translated. Changing the destination IP/port. This is typically done for destination NAT. When traffic from the internet comes in, addressed to a public IP, usually the firewall's public IP, and maybe a specific port, the firewall changes the receiver's address on the envelope to the private IP address of the internal server that should receive the traffic. Example: packet arrives at firewall, source equals internet user, dest equals 203.0.113.5, port 80. Firewall performs NAT. Packet leaves firewall, source equals internet user, dest equals 192.168.1.50, port 80. The destination IP is translated. The NAT policy rules are the configuration that tells the firewall when to perform these address changes and what IP addresses and ports to use for the translation. Without these rules, the firewall would not know how to change the addresses, and traffic might not be able to reach its intended destination or return correctly. Support use cases. Let's discuss how the NAT policy support use cases. The NAT policy on the firewall is designed to handle the two main scenarios where you need to change network addresses. 1. Source NAT, masking internal IPs for outbound. This is for traffic starting from inside your network and going out, usually to the internet. Most networks use private IP addresses, like 192.168.x.x or 10.x.x.x, for computers inside. These private IPs cannot be used on the public internet. Source NAT lets the firewall change the original private source IP address of the internal computer to a public IP address that is valid on the internet. Often, this is one of the firewall's own public IP addresses. This hides, masks, the internal IP addresses from the outside world and allows many internal computers to share a single public internet IP address. Example: your laptop with private IP 192.168.1.5 wants to visit a website on the internet, public IP 203.0.113.10. The firewall's source NAT rule changes the packet's source IP from 192.168.1.5 to the firewall's public IP, say 1.2.3.4. The website sees the request coming from 1.2.3.4. 2. Destination NAT, allowing external access to internal IPs. This is for traffic coming from outside your network, like the internet, and going into a server located inside your network. Your internal server has a private IP address that external users don't know and cannot reach directly. Destination NAT lets you publish your server using a public IP address. Often the firewall's public IP may be on a different port. When external traffic arrives at the firewall directed to this public IP and specific port, the firewall changes the destination IP address to the private IP address of your actual internal server and forwards the traffic. This allows external users to access your internal services without needing to know the private IP. Example: someone on the internet wants to access your web server with private IP 192.168.1.50. They connect to your firewall's public IP 1.2.3.4 on port 80. The firewall's destination NAT rule sees this and changes the packet's destination IP from 1.2.3.4 to 192.168.1.50 and sends it to the internal web server. The NAT policy provides the framework to configure rules that perform either source NAT or destination NAT, supporting these essential network communication scenarios. NAT policy mechanics. Let's discuss the NAT policy mechanics. This is about how the NAT policy actually works inside the firewall to perform the address translations. There are two main things to understand about how NAT policies function. 1. Rule creation. Just like with security policy, the NAT policy is made up of rules. When you create a NAT rule, you need to define criteria to match traffic and specify translation type, parameters. You define criteria similar to security policy, such as source and destination zones, source and destination addresses, using objects, and service, protocol/port. These criteria tell the firewall which specific network traffic this NAT rule should apply to. For example, traffic from the internal zone going to the external zone. Then, you specify the translation type. You choose whether this rule will perform source NAT or destination NAT. Finally, you define the translation parameters. For source NAT, you specify what the new source IP address, or pool of addresses, should be. For destination NAT, you specify what the new destination IP address, the internal server's real IP, should be. You might also specify port translation if needed. This tells the firewall how to change the addresses. 2. Policy evaluation. This is the order in which the firewall checks the rules. NAT policy rules are processed top-down for matching traffic. The firewall starts at the first NAT rule, checks if the traffic matches all its criteria. If it does, that rule is applied, and the firewall stops checking NAT rules for that traffic. If it doesn't match, it moves to the next rule, and so on. Crucially, the NAT policy is evaluated before the security policy. This is very important. The firewall performs the necessary address translation first so that when the traffic is then checked against the security policy rules, it's using the translated, correct, IP addresses and ports. For example, if an internal user's traffic is source NATed, the security policy sees the firewall's public IP as the source, not the internal private IP. If external traffic is destination NATed to an internal server, the security policy sees the internal server's private IP as the destination. So, the mechanics involve building rules that specify what traffic needs translation and how, and then the firewall processing these rules in order before it even looks at the security rules that decide if the traffic is allowed or blocked. Rule creation. Let's talk about rule creation within the NAT policy. The NAT policy on your firewall is built using a list of rules, much like the security policy. When you create a NAT rule, you are telling the firewall, if you see network traffic that looks like this, matching criteria, then change its address information like that. Translation parameters. When you create a NAT rule, there are two main parts you define. 1. Define criteria to match traffic. This is how you tell the firewall which specific network traffic this NAT rule should apply to. You set conditions that the traffic must meet. These criteria are similar to what you use in security policy rules, but focused on the address information before any translation happens. You specify things like the source zone and destination zone the traffic is moving between, for example, from internal LAN to external internet. The source address and destination address involved, for example, traffic from any IP in the internal _users address group, or traffic going to a specific public _web server address object. The service, protocol and port the traffic is using, for example, TCP port 80 for HTTP, or UDP port 53 for DNS. The rule will only match traffic that meets all the criteria you set. 2. Specify translation type/parameters. This is where you tell the firewall how to change the addresses for the traffic that matched the criteria. Translation type. You choose whether this rule will perform source NAT, changing the originating IP, or destination NAT, changing the destination IP. Translation parameters. You specify the new IP addresses or ports to use. For source NAT, you define the translated packet source. This is usually a single public IP address, called dynamic IP and port, or DIP, that many internal computers will share, or a pool of public IP addresses. The firewall will change the internal source IP to one of these public IPs. For destination NAT, you define the translated packet destination. This is the internal private IP address of the server or device that the incoming public traffic should actually be sent to. You might also specify a translated port if you want external users to connect to a different port than the one the internal server uses. So, creating a NAT rule is about precisely identifying the traffic that needs address translation and then clearly defining what the new source or destination address and port should be. Policy evaluation. Let's talk about policy evaluation in the context of NAT policies. Once you have created your NAT rules, The firewall needs to know in what order to check them when network traffic arrives. This is the policy evaluation process. There are two key aspects to how NAT policy rules are evaluated. 1. Rules are processed top-down for marching traffic. When a packet of network traffic arrives at the firewall looks at the NAT rules starting from the very first rule at the top of the list. It checks if the traffic matches all the criteria: source zone, destination zone, addresses, service, of Rule 1. If it matches, the firewall applies the translation specified in Rule 1 and stops checking the other NAT rules for that packet. If the traffic does not match Rule 1, the firewall moves down to Rule 2 and checks it, then Rule 3, and so on, until it finds the first rule that the traffic matches. Only that first matching rule's translation is applied. This means the order of your NAT rules is very important. More specific rules should generally be placed higher in the list. 2. Rules are processed top-down for matching traffic before security policy. This is a critical point in the Palo Alto Networks traffic flow. The firewall evaluates the entire NAT policy and performs any necessary address translation before it starts evaluating the security policy rules for the same traffic. This means that when the traffic reaches the security policy stage, it will have the new, translated source or destination IP addresses and ports, as defined by the matching NAT rule. Example: an internal user, private IP 192.168.1.10, goes to the internet. A source NAT rule matches and translates the source IP to the firewall's public IP, 1.2.3.4. When this traffic is then checked against the security policy rules, the firewall sees the source IP as 1.2.3.4, not 192.168.1.10. Your security policy rules that allow outbound internet access need to be configured to expect traffic coming from the translated IP, 1.2.3.4, not the original private IP. So, the NAT policy acts as a pre-processing step. It checks its rules in order, performs the address change if a rule matches, and then passes the translated traffic on to the security policy for allow, deny decisions and security inspection.